All right, I am here for 52 weeks of AWS, and I'm going to be covering, I'm not AWS, Swift, and I'm going to be covering the inheritance features of the Swift language. And inheritance is kind of a fun topic because it's easy to make it really complex and blow things up. And then you have so much complexity in your code that the inheritance really didn't solve any problems. So I'm going to tackle it first by diving into just walking through the official guide here and just talking about it a little bit. So if we go to the official guide here for Swift and we take a look at inheritance, we go through here, you can see that inheritance it means that you can inherit methods and properties and other characteristics. So a lot of times with inheritance, the method is maybe the central component of inheritance, in that it is something that you can actually use over and over again for every instance of the class, and it may know how to operate on the data that's included in it. And one of the things I've done in the past was to do meta programming in the Python language, where I was able to programmatically create what a class would look like. And then from there, when I was able to inherit from this meta class, it had all kinds of goodies, built inside of there. So it's kind of a similar concept, meta programming versus inheritance, in that meta programming is before the instantiation, but in the case of inheritance, essentially it's happening when you actually make an instance of it. You inherit everything that's associated with that base class, and then you can actually inherit multiple classes and really mix and match behavior. So it's the concepts, I think, are reasonably intuitive. It's the practice really that gets into trouble. So let's go ahead and now get into the Xcode development environment. So I'm going to go through here and share that next. So if we go through here and I get into the playground here, you can see that I've got this playground, and I can actually just start, building out some examples here. So what do we want to start out with? So in particular, one of the things that we can start off with is a base class called a vehicle. Again, this is from the official documentation. So I'm going to go ahead and throw this in here, and let's take a look at this. So we have a class right here. It's a vehicle. We have these curly brackets, and then inside of here we have the the data that's available inside of this particular class. So we have current speed 0, description string, and notice that these are vars, right? So they become mutable. And then we have a function that basically doesn't do anything yet. So if I go ahead and run it, all this does is basically allow for the creation of this. And now if I want to make a new instance, I would use let, and I would make an immutable instance of this. And so if we go through here and we make this, you can see that I've been able to create this vehicle. Now, what are some things that we can do? Well, we can print the data that's included inside of this class, right? And so this would be an instance attribute here. Let's go ahead and print this out. There we go. Look, we see that the vehicle is traveling at 0.0 miles per hour. So without even looking at the additional documentation, you could potentially think about, well, what else could I do to, mutate things? Well, you could actually go and set this value to something, right? You could set this description to some other thing that you wanted to set. So this could be, for example, 4 miles per hour. Now let's cover the next topic here, which is subclassing, and this is the concept of building a new class on an existing class. Go ahead and call this subclassing right here. And so what we could do here is we could say, make a subclass definition right here. So here's some, superclass. Now in this case, it doesn't actually exist, but what we could do is instead we could subclass it by actually using the vehicle we created earlier. So let's go ahead and do this. We'll say class a bicycle. And in this particular example here, it's able to use the information that we defined above in the vehicle. And we're also able to add another attribute inside of here, which is again mutable, which is a var has basket. If I go ahead and run this, we actually are able to let it go. And now if I want to make an instance of this bicycle, we go here, we see that that actually works. And then if we want to do basically a Boolean here and say bicycle dot has basket and say equals true, what happens here, we can actually change the default, right? Before we had set the default class attribute here to has basket, and then in the instance, we were able to actually mutate it. We can also do the same thing with the other attribute that was associated earlier in the original base class, right? So let's change the speed right here. And if we go through here, we can just say bicycle.current speed is equal to 15. And then once I've set this, what's nice is that I can go through and I can change it. So really, it's kind of the concept of reuse, right? I mean, that's really the main idea behind inheritance here. And you can see how you can even go further, and you can actually do a subclass of a subclass. So how would we do this? Well, let's go ahead and do this. Let's do a subclass of a subclass. And if we go inside of here and I say class tandem bicycle var current number of passengers equal to 0, we can actually go through here and do a subclass. And in this particular example, we can say let's tandem. So we make an instance of that subclass of the subclass. We then go ahead and set the new attribute here value. So we say tandem.has basket is equal to true. We can also go ahead and do a current number of passengers, which I believe I defined. Are we adding a new? Oh no, this particular subclass we defined var current number of passengers, and we initialized it as 0. So we can go ahead and change that instance value as well. And then what else can we do? We can change the speed and go through here and do that. And then we can also just print this out. So you can see here that basically we're able to heavily utilize the existing work that we did earlier. And it's able to actually kind of use all those things together. So there are, especially with UI programming, there's a lot of advantages to inheritance because there's things that are really complicated to build, and it can be very valuable to use inheritance to solve those problems. In this example, though, we're just really changing things that are already set, but you can do more. One of the things you can do is you can actually do overwriting as well. So how would we do this? Well, let's go ahead and build this out. And one of the things that we could do here is we could actually go back to vehicle, which, if you remember, had basically a make noise function. And remember that function was basically a no op. It didn't do anything. So what we could do is we could say, hey, let's actually make this do something. The inherited function here, or method, I'm going to overwrite it, and then I'm going to make it say choo-choo, right? So let's go ahead and do that. It's kind of a cool little example. And then if we want to make a train that does the choo-choo noise, we can go through here and we can run this. So kind of a cool little example here, choo-choo, right? Now, overwriting properties, right? We can also do that. But in general, the concept here is that you don't necessarily have to be stuck with what you created initially. You can customize it. You can customize the methods or functions, and you can also, go ahead and customize the attributes or properties that are available as well. So in this case, we have a new subclass of vehicle, and we inside create a new property, which is var gear, again, mutable. And then we override the description available before that was part of vehicle. Because if we go back up to vehicle here, we should be able to see the description, right? Which is this. So we want to change that property. We just go back inside of here, and we can actually make it do something a little bit different. So let's go ahead and run that. And then if I want to make an instance of it, we can actually say let car car.current speed, all that kind of stuff. Let's go ahead and do that. Let's say let car equal to car. We'll make an instance of it. We'll say car.current speed is equal to 25.0. Let's change that to equal 5.0. And then we can go ahead and run that. We can also do car.gear, make it into third gear. And then we can say print, and we can do a print statement here that basically tells us the car description. And so we can say this car is traveling at 25 miles per hour in gear 3, right? You can also override property observers as well, which is another kind of cool trick. And even you can do overrides. You can prevent overrides as well. So really, in a nutshell, inheritance, I think, as you can see, is a pretty cool concept. As long as you keep it light, you don't get too involved with making too many different levels, because as you can see, it could get really lost very quickly. Because if you start subclassing, right, you can just get yourself into trouble. It's better to kind of keep maybe one or two different variations. Also, if you started overwriting everything, you could get yourself into trouble. But there are some nice reusability aspects, especially because if you look at the Swift language, one of the main use cases for it is UI development, either the desktop or the mobile device. And so by giving people the ability to create really like a scaffold with a base class, where then you have some no-op methods inside that you can inherit and you can actually change by overriding them, you really can make a more sophisticated, automated UI development process. And so that's where I would recommend using inheritance, is not necessarily on the business logic side of things. I would recommend using it on the GUI or the UI side of things. And I think that's probably a good place to really consider using the inheritance in Swift. Okay, well, thank you so much. Next week, I'm going to cover initialization. All right, talk to you soon.